the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. Now, this video you're about to see is one of my older videos. The quality is not the same as my new video series. My intent is to make a newer version of this video at some point in the future. However, I want to make sure that students currently using my Mathematics in Review video series have access to as much help as possible when it comes to prerequisite topics. With that being said, let's get started.
We're actually going to start out this example set with something very familiar to us, multiplying out binomials. This will actually give us an idea as how to factor binomials using the guess and check method. The first thing we're going to do when we multiply these binomials, a lot of students like to use the term FOIL, I do not. I'm going to distribute that 2x to each of those terms in the second binomial. And then after I'm done doing that, I'll distribute the second term here, the positive 1, to each of the terms in the second binomial as well. So what we should get in the end is a trinomial, or basically a polynomial, where we have 2x times x, which is a 2x squared, and then 2x times a positive 2, which is a positive 4x. And maybe I'll write that in blue so that it matches with my coloring here. So positive 4x. And then again, to match my coloring, we have a positive 1 times x, which is a positive 1x. And finally, a positive 1 times a positive 2, which is a positive 2. One thing you should note here is where each of these terms comes from. This 2x squared came from 2x times x. And then the last term, these are the most important terms essentially for the guess and check method. We'll see in a moment. But this last term is the number 2, and that last term came from 1 times 2, from these last two objects here in the binomials. By the way, when you write this out, you'll get a 2x squared plus 5x plus 2. Now suppose instead we were presented with this trinomial and we were asked to undo that multiplication. In other words, factor it out. Now without any preparation, not knowing what it factors to, let's just pretend for a moment. The first thing I'm always going to do is try to factor out a greatest common factor. In this case, I look at this trinomial. Each of these terms do not share something in common. I mean, of course, the first and last term do, but all three at the same time do not share something in common. So my only hope for factoring this is to factor it as the product of two binomials. And if it's going to factor as a product of two binomials, then it's going to be something times something else. I have no idea what the other else is going to be. But I do know it's going to have this form, where we just don't know what the coefficients of the x variables are, and nor do we know what the constants are. And actually, to be honest with you, I don't even know if those are going to be pluses there, but for now, I'm just pretending. Once we get good, we'll be able to tell if that's going to be a plus or a minus. Well, one thing I do know is that if I were to multiply this out, or distribute all this stuff through, that I know that the product of whatever this is times x and whatever this is times x should be 2x squared. So here's where the guess and check method starts. You're going to think of two numbers that multiply to become 2. In this case, a 2 and a 1 work perfectly. We still have these other boxes to fill in, but you know that you have some choices for those other boxes. Two numbers that multiply to this last constant here, or the constant term here, would be 2 and 1 or 1 and 2. Now here's where you have to be kind of careful. I'm going to write them down below. That could be a 2 and that could be a 1, or it could be in the other order. Turns out that this makes a difference. If you don't see why, well, let's go ahead and plug it in and find out. So let's pretend we thought it was that the 2 went here and that the 1 went there. Now when you multiply this back out to check your work, which you should always check your work, 2x times a single x, well, that's designed to give us 2x squared. In fact, if you look at the last terms here, when I distribute this 2 to this 1, I'll get a 2 times 1, or in other words, a positive 2. So again, that matches the format of my original trinomial, 2x squared plus 5x plus 2. So I have the 2x squared and I have the 2. I just want to see if when I multiply the inside and the outside terms that it comes out to be a 5x. So let's see what happens when I do this. I'll do the little distribution up top. 2x times 1, and then a 2 times 1x. So when I write those in, positive 2x plus another 2x, and you can see right now that it's not going to work out. This is actually equal to 2x squared plus 4x plus 2, which is not what I wanted. So we have to be a little more creative with our choice here. Luckily, when we hop back here, you can see, well, we tried this option where we put the 2 here and the 1 here, so it has to be the other option. So I'm going to go ahead and cross these out. This doesn't work. So it's likely to be the other option. Let's go ahead and try that other option out. Let's hop back here. And the other option was, instead of placing the 2 here, we're going to place the 1 here, and vice versa. When you multiply this out, you get 2x times 1x, which is a 2x squared. You get a 2x times a 2, which is a positive 4x. And you get a 1x times, or 1 times 1x, which is a positive 1x. And finally, a positive 1 times a positive 2, which by the design will always work out. The last term and the first term are designed to always work out. You almost don't have to worry about those. What you have to worry about is finding this middle term. By the way, this turns out to be 2x squared plus 5x plus 2. So we know that that is the winner for our factorization. I'm just going to put the plus 1 here and the plus 2 there. Therefore, our trinomial factors into 2x plus 1 times x plus 2. Now at this point, that's somewhat of a lengthy method when you first learn it, but when you're good at it, it goes very quickly. A shortcut to kind of take note of is that once you make your selections for the coefficient on x, so 2x and a 1x here, and our constants, the 1 and the 2 or the 2 and the 1, they're always going to multiply out to become the lead coefficient times x squared and the constant term. We all notice with both of our examples back here, they both had ended up with a 2x squared and then a plus 2. Here's 2x squared and a plus 2. So that part is not really in question. The part that's in question is the middle. Can we get the 5x? And so this is where I introduce kind of the language, the inner-outer step. The inner-outer step is basically when I'm questioning if this is going to be true or not, I'll say, okay, well, let's test the inners and outers. So the inners would be 2 times 1 in this case, and the outer would be 2 times 1. Well, that's 2 and 2. Is there any way for 2 and 2 to become 5? And the answer is no. So then I try the other inner-outers. Inner again, this 1 times this 1 will give me 1. So when I multiply those two. And in the outers, 2x times 2. Well, 2x times 2 is 4x. So I have 1x and a 4x. Is there some way to combine those to get 5? Yes. So that must be my winner. Okay, in this question, we're being asked to factor 6r squared minus 19r plus 3. So I first ask, again, is there a GCF, or can I factor out something that's common to all 3 terms? In this case, there's really nothing common to all 3 of those. So now we move on. And hopefully, this can be broken apart into the product of 2 binomials. Now, sometimes it cannot, but hopefully this one can. We're going to start by asking the same questions. We have this 6r squared, so I know that the product of the coefficients on the r's have to become a 6r squared. Well, that gives us several choices. So I can't just immediately fill in what these are. It's either a 1r and a 6r, or it's a 2r and a 3r. Both of those will lead to a product of 6. And actually, if you look at this, the back end here, there's only one way to get a positive 3 from the product of 2 numbers. It's a 1 times a 3. Now, there's something to note here, is that there is a negative on this middle term. We'll approach that in a moment. But for now, I know that 1 and 3 is going to be a good choice here. Now, remember what I said earlier, that order does matter. Like, we're going to have to both write the 1 and the 3, and then the 3 and the 1. So you notice how many choices we have. We actually have quite a few choices here. When we start doing this, you'll find out that it's going to take a little bit of trial and error. Now, a little hint is that often authors are pretty predictable in how they write these problems, and they write them so that they factor to where they're not like a 1r times a 6r. They're usually like the 2r and the 3r. So here's a little hint. Try combinations without the ones first. I know that it's really just a tactic, but it does save time, especially when you're factoring, trying the ones with, or trying the factorizations without the ones. So in other words, instead of trying 1 times 6, I'm going to try the 2 times 3 first. So here's how I'm going to do it. I'll write 2r and I'll write a 3r because I know the product of 2 and 3 is going to give me that 6. So I'll have a 6r squared. And now I just have to see, okay, do I want to place the 1 here and a 3 there, or do I want to go the opposite? And this is where you're doing the inner and outer. So here we go. Let's do the inner first. 1 times 3, that'd give me 3. So I'm just looking at it this way. 1 times 3, and then 3 times 2. So I have 1 and 3, which gives me 3. 3 and 2, which gives me 6. So I have a 3 and a 6. Is there any way to combine 3 and 6 to get to 19? No, that's not possible. So this one is already out. The next one, do the same business, inners, outers. So here are the inners. 3 and 3 is 9. 1 and 2 is 2. So 9 and 2. Is there any way to combine 9 and 2 to get to 19? No, there's no possible way. When I say any way to combine, I mean through addition or subtraction. So interestingly enough, the combinations without the ones first, in other words, instead of trying 1 and 6, we tried 2 and 3. It didn't work out well for us, but that doesn't mean that it won't always work. In fact, almost always speeds up the process. This just has to be a rare occasion where obviously the 2 and 3 aren't the choice that we should have gone with. We should have gone with the 1, 6. So let's go ahead and switch gears and write down the 1r here and the 6r there. And again, I'm going to write down my possible combinations. This could be a 1, this could be a 3, or this could be a 3, and this could be a 1. There's a lot of other techniques to doing this, but I like one technique to cover most bases. So now we're going to go ahead and do the inner-outer technique here. Let's see, for the first choice, we'd have inners would be 6, outers would be 3. Any way to combine 6 and 3 to be 19, that's a no, so I'll cross that out. So I already know it's going to have to be this last one. It's our only other choice, but let's just check it anyway. 3 times 6 is 18. 1 times 1 is 1. So 18 and 1, any way to get to 19? Yes. So this is my winner. And I'll just plant it right in here. So this will be a 3, this will be a 1. And now we need to ask ourselves the signs of these. And this is why I mentioned in the first example that I won't always write the plus automatically, because the fact is we're multiplying 3 and 1 to become a positive 3. But then we're going to add 18 and 1 to become a negative 19. So it better be a negative 18 and a negative 1. And actually, that's not bad to do. If you look at this, negative 18r, and then a minus r would be a negative 19r. But a negative 3 times a negative 1, well, that's positive 3. It's okay that they're both negative because the product of two negatives is positive, and the fact that they're both negative helps us get that negative middle value. Okay, so the actual factorization here is r minus 3 times 6r minus 1. So let's try this again. This one is, again, something that I'm going to take a look at and say, is there something that we can factor out that's common to each term? In this case, again, there's just nothing that they have in common. So I know that this, or hope actually, that this can be broken down into the product of two binomials. And if you take a look at the coefficient on the t-squared, the lead coefficient there, it's a 5. There's only one way to break 5 apart, 5 and 1. And now I just have to think, how many ways can I get a 10? Well, 1 and 10, or 10 and 1, 2 and 5, or 5 and 2. Those are the only ways to do it. And again, I'm going to go with my hint that I said earlier, trying the factors without 1 first. So in other words, I'm going to skip the 1, 10, 10, 1 business and go right down to the 2 and the 5 here. Okay, inners, outers. Let's see, I have 2 times 1 is 2. 5 times 5 is 25. So we have a 2 and a 25. Let me just write this down. A 2 and a 25. Any way to combine those numbers to get to a negative 23? Sure there is. If that 25 was negative, then 2 minus 25 being negative 23. So this looks to be my winner. I'll go ahead and write the numbers up here. I just have to decide where the negative goes. Let's see, we wanted 2 times 1, 5 times 5. Oh, I see that 5, since we want a negative 25, that 5 is going to have to be negative. That 2 will have to be positive. Again, always check your work here. First things, 5t times t will give me 5t squared. That's always by design. And then 5t times a negative 5 will give me a negative 25t plus 2t, so that'll give me my negative 23t. And then finally, positive 2 times a negative 5 is a negative 10. So that is actually how it factors out. So you can see that as you move through these, it gets faster and faster and faster as you kind of get used to this. It also kind of challenges you to think while you do mathematics. Factor 12y minus 2y cubed minus 2y squared. Again, as I have always said, factor out the GCF first. In this case, if you write this, you can always rewrite this in descending power order. So you have a negative 2y cubed minus 2y squared plus 12y. You look at these three terms, they do share something in common. They all are divisible by 2, and they're all divisible by y. So I could take out a 2y, but there's something even more important to note about this. So let me just factor out the 2y first. Let me start like that. It's very important for you to also make sure the lead coefficient is positive. It will help you immensely if you make sure the lead coefficient is positive. And as this hint says, whenever you start with a trinomial where the lead coefficient is negative, you're going to go ahead and factor out a negative 1 as well. So in this case, I'll factor in negative and then 2y out of all this. So this first term, if I divide out a negative 2 and then a y off of it, I get a y squared. The second term, if I factor off a negative 2 and a y, I get a positive y. And the last term, if I factor out a negative 2y, I'm left with a negative 6. This is actually not too bad to factor at this point, because remember, we still have that negative 2y hanging out there. There's nothing else they have in common, so hopefully this factors nicely. Two numbers. I know this is going to be a y and a y, because 1 times 1 is the only way to get to a 1y squared. And just think of two numbers that when you multiply them, they multiply to negative 6, but they add together to become a positive 1. 2 and 3 seem to be good candidates, because 2 times 3 is 6, and you can manipulate those to become a positive 1 if you subtract 2 from a positive 3, and you can also see that negative 2 times positive 3 is that negative 6. So that is actually our answer. Although that did not involve the guess and check, it's still sort of guess and check because we're still critically thinking about it.
Thank you for watching this review video. As I mentioned previously, it's an older video that will eventually be updated. However, it should get the job done for you. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you review any prerequisite material mentioned in the video. If you find you're continually having to research the prereq material here, you might want to consider speaking to your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.